Okay, so here we go. We're going to try some of these trig comparisons. Alright, so let's look at this one, the sine of 120 versus the sine of 150. Okay, so let's see. I'm going to draw this on the same set here. So 120 and 50, let's see, they're both in second quadrant. So 120 is an angle that's right about here, and its reference angle, if that's 120, its reference angle is 60. And then 150 is going to be, let's see, let me grab a second color for myself. Okay, and its reference angle for ourselves, right, for myself. Okay, okay, number 12. Oh, those are both in the first quadrant. So I'm going to again draw that arc for a circle for myself, just to help me make that radius equal. And if you good to use pencil so you can really make it. And let's see, 50 I'll use the pencil for. That's about halfway. Right, there's the triangle for that one. 80 I'll use the pen for. Right, that's almost 90, so there it is. Okay, there are my points as I'm using them. And remember that cosine uses the adjacent, and the adjacent are the x values. So you're looking at the x values you have for these two. Which has a larger x value? Oh, it's 50. All right, so we have a greater than sign there for that one as well. Okay, that's all it comes down to when you're doing these. Right, it depends on the quadrant you're in. You're kind of just comparing your reference angles as you do it. If it's in the first quadrant, your angle is the reference angle. If it's in the second quadrant or third or fourth, you just have to figure out what that reference angle is going to be. Right? Sometimes it's easy enough to do just based off of knowing what quadrant you're in or knowing where it's located. So if I'm looking at tangent of 180 versus sine of 90, okay, for myself, right, 90 degrees would be an angle straight up here. Oh, I'm sorry, I should do that with pen. So 90 degrees is right up here. Again, let's put that circle for myself. Okay. For myself. So the y value there looks to be pretty high. The tangent is 180, so that's down. Here's 180 degrees. Right here it is. And remember, tangent's opposite over adjacent. Opposite's always y, adjacent's always x. So at this point down here, I can see my y value is 0, so tangent of 180 is 0. And the tangent of 90 then is definitely larger there. So I'll put a less than symbol because the sine of 90 is larger. So because remember, sine uses the y value, right? So that's where I'm looking. That's where I'm getting that from. So you're just looking at all those comparisons as you do this. Do the best you can to compare it. Right? Some people that get worried when there's radians, and actually, just like I was telling you before, I think that a lot of times those are, well, maybe they're not easier in this case. You just have to think about how close they are. So 5/7 and 4/5, well, we have 0, pi over 2, and pi. So they're both between 1 and 1.5. So if I draw my circle here to help me with that, keep my radius consistent. 4/5 is 80% of the circle, so 80% is down here. All right, so that's where mine's going to be. Draw my triangle, my reference triangle in. 5/7 is actually not quite 80%, so it's going to be up here. And it doesn't matter where it is. Remember, we're just doing comparisons. So if you're not perfect, that's okay. Just looking at comparing them. Okay. So these are our comparisons. So we're doing secant, which uses the x values. So we're looking at the x values of these. So which one is a larger x value? Oh, well, this one in pencil's further to the right, so the x value is larger here. I know that they're negative, but it doesn't really matter. If it's larger, it's further, further to the right on the x-axis for myself. Don't look at the length of this length here, because that's, you're looking at the magnitude of it. We're actually looking at the x values, and since it's negative, that one's further to the right, and therefore it's larger. Okay. Oh, but wait, it's secant, so it's a reciprocal. Well, if you flip a number, that means the denominator is larger for this one in pencil. The denominator is larger, that means your fraction overall is smaller. So let me see it. Think about that one more time. This one in pencil has a larger denominator, right? As a larger x value, which when we flip it and do the reciprocal function, makes it a larger denominator. Larger denominators make it a smaller fraction, and that's where we're getting that from. Wow. Okay, so they can get a little tricky. So do the best you can on this, right? Rewatch the video if you need. Give it your best shot. You can always plug these into your calculator, right? You know, just to check your answers. You can plug in like tangent 210 and secant 150 to your calculator to kind of confirm your answers and see if you're really doing it right. But really, these are non-calculator problems. We're not going to use that, as it says, without using a calculator. But to check your work, you could use a calculator. Okay, good luck on these, folks.